Hello students, myself Purva Joshi, Assistant Professor at LG Institute of Engineering and Technology. Today we will discuss few more topics of indeterminate forms. So let's begin with the first one, that is indeterminate form of the type infinite by infinite. Problems under this type are solved by using L'Hopital's rule, considering the fact that if limit extends to a f of x tends to infinite and limit extends to a g of x tends to infinite, then limit extends to a f of x upon g of x is equal to limit extends to a f dash x upon g dash x. Okay, so whenever we have the form infinite by infinite, then also we will apply L'Hopital's rule. Okay, so in this, what we have to do, we have to take the derivative of numerator and denominator separately. Okay, now let's begin with the example. Evaluate limit x tends to pi by 2 log x minus pi by 2 upon 10x. Let's begin with the solution. Now take this limit as L. Okay, and now if you will substitute x is equal to pi by 2 here, so you will get log pi by 2 minus pi by 2, that is log 0 upon 10 pi by 2. Okay, now this will give the form infinite by infinite. Okay, so we will apply L'Hopital's rule, means we have to take derivative of numerator and denominator separately. So first take the derivative of log x minus pi by 2. So it will give 1 upon x minus pi by 2, and derivative of the next will give sec square x. Okay, now we will rearrange. So bring this sec square x in the numerator. So 1 upon sec square x will become cos square x and upon x minus pi by 2. Now if you will substitute x is equal to pi by 2, so you will get the form 0 by 0. Why? Because we know the answer of cos pi by 2 is 0 and this pi by 2 minus pi by 2 is also 0. So we will apply L'Hopital's rule, right? So first apply derivative here. So you will get 2 cos x into derivative of cos x, that is minus sin x, upon derivative of x minus pi by 2 is 1. Okay, now substitute x is equal to pi by 2 here, so you will get the answer 0, because the answer of cos pi by 2 is 0. Okay, so the final answer of a limit is 0. Now next example. Here we have to prove that limit x tends to infinite 1 square plus 2 square plus 3 square plus so on up to x square upon x cube is equals to 1 upon 3. So let's begin with the solution. LHS we are taking as limit x tends to infinite 1 square plus 2 square plus 3 square plus so on up to x square upon x cube. Okay, now we know this formula, that is summation of n square. It is n into n plus 1 into 2n plus 1 upon 6. Okay, so we will apply this formula. So you will get limit x tends to infinite x into x plus 1 into 2x plus 1 upon 6, and this x cube as it is. Okay, now if you will substitute x tends to infinite, you will get the form infinite by infinite. Okay, now to simplify it further, what we will do, we will take x common from this both the bracket. Okay, so this first x as it is, take x common from this bracket, so you will get x into 1 plus 1 upon x. Take x common from this bracket, so you will get x into 2 plus 1 upon x upon 6x cube. Okay, so now this x will get cancelled, and what will remain is 1 plus 1 upon x into 2 plus 1 upon x upon 6. Now we know this limit x tends to infinite 1 upon x is equal to 0. So these two terms are 0. So what will remain is 1 plus 0 into 2 plus 0 upon 6. On simplifying, you will get the answer 1 upon 3. Okay, so this is what we want to prove. Now, let's move to another example. Prove that limit x tends to infinite x raised to m upon e raised to x is equal to 0, and here m is greater than 0. So let's begin with the solution. LHS is given, that is limit x tends to infinite x raised to m upon e raised to x. So if you will substitute x tends to infinite, you will get this form, that is infinite by infinite. So we will apply L'Hopital's rule. So on applying L'Hopital's rule, you will get limit x tends to infinite, derivative of x raised to m, that is mx raised to m minus 1, and derivative of e raised to x is again e raised to x. Okay, and if you will substitute infinite, so you will get the form infinite by infinite. So again we have to apply L'Hopital's rule, right? So on applying L'Hopital's rule, you will get m into m minus 1 into x raised to m minus 2 upon e raised to x. Okay, so again if you will substitute x tends to infinite, you will get the form infinite by infinite. So we have to apply the same procedure up to m minus 2 times. Okay, so you will get limit x tends to infinite, m into m minus 1, m minus 2, m minus 3 up to 2 into 1, and derivative of this e raised to x will be e raised to x. Now on simplification, you will get limit x tends to infinite, m factorial upon e raised to x. Okay, now if you will apply the limit, you will get m factorial upon infinite. Now we know 1 upon infinite is 0, so final answer is 0. Okay, now this is what we want to prove. Now another example, prove that limit x tends to 0, log sine 2x base sine x is equal to 1. Let's begin with the solution. Consider this LHS. Okay, now we will apply the log formula. Okay, so you will get limit x tends to 0, log sine 2x upon log sine x. Now if you will substitute x is equal to 0, so you will get log 0 upon log 0, right? So you will get this form, that is infinite by infinite form. So we will apply L'Hopital's rule. So on applying L'Hopital's rule, you will get 1 upon sine 2x into derivative of sine 2x, and in denominator you will have 1 upon sine x into derivative of sine x. Simplify, so you will get 1 upon sine 2x into derivative of sine 2x, that is 2 cos 2x. 1 upon sine x as it is, derivative of sine x is cos x. Okay, simplify this, so you will get limit x tends to 0, 2 cos x into, bring this sine x in the numerator. So 2 cos 2x into sine x upon sine 2x into cos x. Now we will apply the formula of cos 2x, that is cos square x minus sine square x, and the formula of sine 2x, that is 2 sine x cos x. Okay, so you will get this term. Now sine x will get cancelled, 2 will get cancelled. What will remain is cos square x minus sine square x upon cos square x. Individual divided, so you will get limit x tends to 0, 1 minus 10 square x. Okay, and now if you will apply limit, so you will get the answer 1, because the limit x tends to 0, 10x is equal to 0. Okay, so this is what we want to prove. Now let's study indeterminate form of the type infinite minus infinite. So to evaluate the limit of the type limit x tends to a fx minus gx, when limit x tends to a fx tends to infinite and limit x tends to a gx tends to infinite. So if both this limit will tends to infinite, so you will get this form, that is infinite minus infinite. Okay, so what we will do, we will reduce this expression in the form 0 by 0 or in the form infinite by infinite by taking LCM or by rearranging the terms. Okay, and when you will get this 0 by 0 or infinite by infinite form, then we will apply L'Hopital's rule. Okay, so let's begin with the example. Evaluate limit x tends to 1 into 1 upon log x minus x upon x minus 1. Okay, so let's begin with the solution. Here consider this limit as f. Now if you will substitute x is equal to 1, so here you will get 1 upon log 1, okay, minus 1 upon 1 minus 1. So here you will get 1 upon 0, so infinite minus again 1 upon 0, so infinite. So here we have the form infinite minus infinite. Okay, so to simplify this, we will cross multiply it, or you can say you have to take LCM, right? So multiply x minus 1 here and multiply log x here. So you will get x minus 1 minus x log x upon x minus 1 into log x. Okay, Now if you will substitute x is equals to 1 here, so you will get the form 0 by 0. Okay, so now we have 0 by 0 form, so we will apply L'Hopital's rule. Okay, now the derivative of x minus 1 is 1 minus, now derivative of this term. So for this we have to apply uv rule. Consider this x as a u and this log x as v and apply uv rule. So you will get x into derivative of log x, that is 1 upon x, plus log x as it is derivative of x 1. And in denominator again we will apply uv rule. So consider this as u and this as v. So log x as it is derivative of this x minus 1 is 1 plus x minus 1 as it is derivative of log x is 1 upon x. Okay, this x will get cancelled, 1 minus 1 0. So what will remain is minus log x upon log x plus x minus 1 into 1 upon x. Now what we will do is we will multiply this x here and we will take this x in numerator. So you will get minus x log x upon, multiply this x here, so you will get x log x plus x minus 1. Now if you will substitute x is equal to 1 here, so you will get the form 0 by 0, right? So whenever we have 0 by 0 form, so we will apply L'Hopital's rule. So what we have to do, we have to take derivative of numerator and denominator separately. So firstly we will do the derivative of numerator, that is minus x log x. Okay, so d by dx of minus x log x is equals to, minus is kept outside, x as it is derivative of log x is 1 upon x plus log x as it is derivative of x is 1. This x will get cancelled, multiply minus sign inside, so you will get minus log x minus 1 upon, again here to solve this we will apply uv rule, right? So consider this as u and this as v, and on simplification you will get log x plus 1 like this, right? And derivative of x minus 1 is 1. Now on simplification and putting x is equals to 1 limit, you will get the answer of limit l is equals to minus 1 by 2. Okay. Next example is evaluate limit x tends to 0, 1 upon x square minus 1 upon sine square x. So now let's begin with the solution. Consider this limit as L. Okay, so L is equal to limit x tends to 0, 1 upon x square minus 1 upon sine square x. Now if you will substitute x is equal to 0, so here we have 1 upon 0, that is infinite, minus 1 upon sine 0, that is 0. So again 1 upon 0, so infinite. So again we have this form infinite minus infinite form. So what we will do is we will cross multiply. So multiply sine square x here and x square here. So you will get sine square x minus x square upon x square sine square x. Okay, now if you will substitute x is equal to 0 here, you will get the form 0 by 0. Okay, now to simplify this further, what we will do is multiply and divide by x square. Okay, and simplify further, so you will get limit x tends to 0, sine square x minus x square. This x square and x square will give x raised to 4 and bring this sine square x here, so you will get x square upon sine square x. Now we know this limit x tends to 0, sine x upon x is equals to 1, right? So this answer is 1, and what remains is limit x tends to 0, sine square x minus x square upon x raised to 4. Now if you will substitute x is equal to 0, so you will get the form 0 by 0. Now we will apply L'Hopital's rule. Okay, so derivative of sine square x is 2 sine x cos x minus derivative of x square is 2x upon x raised to 4. So derivative of x raised to 4 is what? 4x cube. We have to just simplify this. 2 sine x cos x will give sine 2x minus 2x upon 4x cube. Okay, now if you will substitute x is equal to 0 here, you will get the form 0 by 0. So we have to apply L'Hopital's rule, means we have to take derivative of numerator and denominator separately. On derivative you will get limit x tends to 0. From here you will get 2 cos 2x minus 2 upon 12x square. Again if you put x is equal to 0, so you will get the form 0 by 0. Okay, then apply L'Hopital's rule, take derivative, so you will get minus 4 sine 2x upon 24x, again 0 by 0 form, so again we have to take derivative, so you will get limit x tends to 0 minus 8 cos 2x upon 24. Now substitute x is equal to 0 here, so you will get minus 8 upon 24 because cos 0 is 1. Okay, so you will get the final answer of limit on simplification as minus 1 upon 3. Right? So I hope you have understood in this session. Thank you for watching.